you supposed to like go all the way out? I don't know for my stuff, but I got that. I know I've done it, but at the same time, that fraction always fraction, and the one of them always could be. Oh, yeah.
What time is it? What's up?
They say something I am too.
All right, guys.
I am doing someone of mine.
Sorry. We break into the conversation. Let's take a look at these. Are there any votes for what might be the hardest problem on there? Sequence? Yeah?
Anything with an X or Y.
Anything with extra one? Fractions, that's what I thought of here is the fraction one, yeah. All right, so one thing we're going to discuss throughout the semester is one of the most interesting and hardest parts of teaching is to take the time to figure out the logic your student applied to a problem. You're going to see students making mistakes. And if you're going to be a good teacher, you're going to try to tease out why did they make this mistake? What were they thinking about correctly? What did they misassume or something? And try to make a connection with them. So I often have people make mistakes, but they're not like completely not aware of the concept. They just did something that's not legal in this case. It might work sometimes. You guys kind of see what I'm saying? And that takes time. That takes time to really trust me. Oh my God, sometimes you get some crazy stuff. I'm like, oh, I see what you're thinking. Oh, okay. So it takes a little bit. That very first problem. Now, what that very first problem is all about is everywhere. It never goes away. But what's that very first problem primarily about? PEMDAS. Yes. Please excuse my dumbass son. Yes? Or dear Aunt Sally. One semester I had a class that came up with, please excuse my deficient algebra skills. That's what they came up with, not me. Okay. But real quick. I will apologize if you ever had a teacher. I've seen teachers do this. Here's PEMDAS, yes? PEMDAS. Okay. That's not a good way to write it because we could have written it like this and it would have meant the exact same thing. Which one's easier to say? PEMDAS. Which one makes you sound drunk if you try to say it? PEMDAS. It's not me, officer, it's math. Why either way? Because multiplication and division have the exact same importance. Neither one comes before the other one. You do them as they show up. I have seen teachers teach multiplication comes before division, and I tell them, stop teaching that or stop teaching. Yes? That is bad. Do you guys understand that there is no division? There is multiplying by the reciprocal. There is no subtraction. There is adding the additive inverse. Yes? You guys kind of understand? Kind of with me? Therefore, since division is multiplication, neither one trumps the other one. Just use a horrible word. I'm sorry. Yeah, I got it here. I don't know where anybody stands. So the way I write this is PEMDAS. Definitely parentheses first, then exponents. Multiplication, division as it comes. Addition, subtraction as it comes. Yes? Okay. So with that in mind, if I look at this, what's the very first thing I have to do? Parentheses. What's inside the parentheses? So then, if we do 3 plus 4 minus 2, remarkably enough, is 2. The most common mistake I see is people will make this 6. And if you did that, I'm sorry to tell you that was a mistake. What is the only number that's dividing? The only number that's dividing? 2. So if you make it 6, that's not fair. Do you see what I mean? If division could also be, I could put the thing underneath. the 3 would not go with it, would it? Because I'm multiplying by 3, I'm not dividing by 3. Do you guys see that? Okay, I don't go on Facebook very often, thankfully, because it's crap. But if I do go in there, I'll see somebody post an order of operations problem, and then you see this argument underneath, and I'm like, no, stop. All right, what's the very next thing I should do? Exponents. What is the last thing I want to do? Make a mistake. No, what's the last operation I want to do? Add. Because where's addition? It's at the ass end appendix, yes? Okay. So I'm going to do that. The 3 plus is just coming for the ride. 3 plus I don't know yet. 3 plus I don't know yet. So you guys said exponents next. 2 squared. That's crazy. What's next? Yes, this is all division multiplication, so I do it as it comes. 4 divided by 2 is 2. 2 times 3 is 6. 3 plus 6 is 9. Okay. You guys with me? Did anybody get that? You guys? Okay. Does it make sense? And it's really easy. Now, this is remarkably basic, but you don't think about it very often. You don't get a lot of problems where it's everything about the problem, right? But this one is just a straight up order operations problem. You have to understand it because you're going to have to teach it. Yes? So that's what I need you to understand. I can't force you to like something, and I can't force you to understand it, but I'm going to try to get you to a point where you can understand it well enough where you can explain it. Yes? Okay. And the thing about what I said about division doesn't exist, maybe don't tell that to very young students, but at some point you can say that. You can say, realize that that's why they have the same level of importance, because they actually are the same thing. Okay. What's going on with this guy? This guy here, what would you say is the primary idea behind that problem? I'll take 2 things. What about x and y? Combining like terms. There's also, what's the very first thing I should probably do? Yes, and which means what? Do what with us? And what are you distributing? -2, good. So I got 5x minus 3y plus 10y minus 2x, good, plus 10y. And then if you wanted to, what I normally do with students is I'll have them underline the like terms with different underlinings. You see that? So then how many x's do I end up with? 3. 5x's minus 2x's is 3x's. That's crazy. And then if I look at my y's, my positives add up to be 20. Minus 3y is, that's insane. So I get 3x plus 17y. Now, for some reason, students will set that equal to 0 and try to do something. And I'm like, that's very nihilistic. Do you guys know about nihilism? Where you're like, nothing matters. Nothing matters. The whole universe is going to crunch down, and So that's nihilism. And so to me, when you set everything in the world equal to 0, I'm like, holy shit. Everything is 0. So that's not an equation. I can't suddenly make it become an equation. Yes? Okay. Here's somebody's vote for hardest problem on there, which I understand. Now, if you got this, you don't have to speak up, but if your student gave you 4 over 4 equals 1 as the answer to this, do you see where that came from? What'd they do? How did they get 4 over 4? Yeah, 11 minus 7 is 4. 12 minus 8 is 4. 4 divided by 4 is 1. How could you very quickly get them to at least understand the answer cannot be 1? You guys, is everybody with? Can everybody see how a student could do this and get the answer of 1? 4 over 4. What is the quickest way just to say it can't be 1? That's impossible.
We're not. It's smaller.
Okay. How does this number by itself relate to 1? Is it bigger or smaller? 11 twelfths. Smaller, because the numerator is smaller than the denominator. Yes? So I'm taking a number that is less than 1, and I'm subtracting something from it. Yes? Now, that doesn't explain to the student how to do it. It doesn't explain anything beyond what you thought it was can't be what it is. But that is the very first step. What are you developing if you take them through that? What are you helping them develop for themselves? So what did I just take you through? They got an answer, and I with your help, we walked them through why that answer is wrong. That doesn't explain what to do, but what can they do for themselves if they see that model a few times? When they do a problem, they can step back, doesn't make sense. You with me? They can at least realize in a lot of situations, you can kind of check, does it make sense? I might not know what I did wrong, but at least I can see, oh, this doesn't make any sense. How the hell can the answer be 1 when I'm subtracting from something less than 1? I can't do it. You guys kind of okay, now what is the correct way to do this, of course? Fine, come on. Yes. What method do you guys use to get the LCD?
Multiply by 2 for the 12 and multiply by
Now, how did you know to multiply by 2 and by 3?
to get them up to 24.
So 8 and 12 are not very big. So one method you could use, well, what method? If you start with 12 and start doing multiples of 12, 12, 24, and then you go, oh, 8 goes into 20, yes? That is the most basic way to do LCD, is to develop a list of multiples and see where they meet. Okay, I like it. Let me show you a different way. This problem is not too crazy, but you know fractions get crazy. What number do 12 and 8 have in common? 4. 12 is 4 times 3. 8 is 4 times 2. Holy shit. So what is the first fraction missing that the second has on the bottom? What's he missing? He's got a 4, so does he. What's the first missing that this guy has? What does this guy have? A 4 and a 2. What does this guy have? 4 and a 3. So what is this guy missing that this guy has? A 2. He's got a 4 and a 3. He's got a 4 and a 2. This guy's missing a 2, correct? What is this guy missing that this guy has? Doesn't that match up with what you just told me? Give this guy a 3, give this guy a 2. That's another way to see. If you see what they both have. Does anybody have kids? Yes. It's probably a good thing I don't, because you give 2 kids ice cream, and you put sprinkles on one, you forget the other one. What's going to happen? You got sprinkles on. Okay, come here. You got more sprinkles. Okay, come here. You got more ice cream. I would just eat that. Nobody gets ice cream except me. So it's probably good at all kids. So I always look at this as, oh, he got sprinkles. Okay, I'm going to give you sprinkles. Oh, he got more ice. Okay, I'm going to give you more. So you make them equal, or at least as close as you can. I don't know if that helps. If you don't have kids, you were a kid, so you can experience it. So times 2, times 2, times 3, times 3. What's the bottom become then? 24. And what's 11 times 2? 7 times 3? And then you get 1/24. Kapow! Okay. Now, real quick. This class is probably the only class where I get the most diverse backgrounds. I have students who take this class who took Algebra 1 13 years ago. And then I got students who take this class who took Calc 3 last semester. You guys with me? So I have a broad range of abilities. I took painting class in college. Now, come to find out, I actually don't do a bad job painting. I actually still paint today, but when I started painting, I sucked. I had no idea what the hell I'm doing. And the kid next to me had been painting since they were 3 or something. They're like, "Blah, there's a painting, blah, there's a painting." I'm like, oh shit, So you can't compare yourself to other people, right? Other people have taken different paths that have gotten them to the point where, like, I want to become a teacher. So some of those paths had more math than possibly the path you took. So what I'm trying to say is, if you totally understand a problem I'm doing, just sit there and wait, right? If I am not making sense or I'm going too fast, so if I'm going too fast, slow me down. If I'm going too slow, deal with it. Okay. What about these? These are normally people's worst things. They kind of, this is kind of related to word problems eventually, yes? 5 less than 3. How would you immediately rewrite that in Macish? Yes, and that's English is evil. If anybody learned English as a second language, you know all too well, English sucks. It really doesn't make much sense. If you grew up in it, you're like, what are you talking about? Well, it's a lot of Americans that don't understand English. 5 less than 3. It's not math's fault. The less than just makes it turn around. That's actually 3 minus 5, right? Okay. And what is 3 minus 5? Negative 2. Okay. 2 more than the product. Now, what does this word mean? Multiply. So 2 more than the product of 9 and 8. Yes? And then, of course, PEMDAS comes into play. PEMDAS never doesn't come into play. Go complain to your English teacher about double negatives I just used. I don't care. What do you do first? 2 plus 9 times 8? 9 times 8 is 72. Plus 2 is 74. Now, I need you to understand, this is actually something we're going to do in chapter 9. Yes? So in terms of this class, we're not going to talk about solving algebraic equations. There'll be a little bit in chapter 1. But then primarily it's chapter 9 where we're talking about how to teach it. Yes? This is more me just trying to make sure how much you guys remember about just algebra. Okay. I heard some good discussions about 3A. Can somebody tell me what you guys did first on 3A? I mean, what's the overriding idea of solving an equation for x? Get all your x's on one side, all your numbers on the other side, and the last step is almost always divide. Yes? So it doesn't matter which side you put all your x's, but I would highly recommend you keep your x's positive. Because then you're not going to have to divide by negative, which is just another place for humans to make a mistake. Right? And I love it when I say that because it sounds like, are you human, Jeff? So I would subtract 4x. If you didn't, just hang on. We'll see if we get the same answer. What do I do next now? I've chosen what side to put my x's, so I have to move all my numbers to the other side. So add 3. Add 3. Add 3. So what this means, the right way to interpret an answer to an equation is when this statement is true, then this statement is true. That's how you interpret it. How do you check your work? Plug it in. Good. So this one, what do I have to do first? Distribute. I like it. 3x minus 6 equals x plus 2x minus 6. Did anybody work this out and not understand what to do? 3x minus 6 equals 3x minus 6. Let me get my x's together. Now, real quick. Is everybody with me so far? You might not have understood the next step, or maybe you did. So, my man back here who said the x's and the y's. Students hate the variables, but what's really funny is right here, they will do everything they can to save it. Like, oh no, x, let me save you. No, let it die. Look, x is dying. Let it die. Right? I'll always have somebody that just puts an x. And I'm like, here, what? He's dead. He's dead. What's the only thing left? Now, what did I say how to interpret the result? When this statement is true, then this statement is true. When this statement is true, then this statement is true. Is this ever not true? Does negative 6 ever not equal negative 6? Every fourth Tuesday, Jeff. No. So negative 6 is always negative 6. Therefore, this equation is always true, no matter what value of x you put in. Do you understand? This is actually ends up being a definition of freaking distribution, so it doesn't matter what x is. Are you guys with me? If it would have said negative 6 equals negative 5 at the end, what would the answer be then? Is negative 6 ever equal to negative 5? No. So then the answer would be no solution, because it would never work then. How do you guys feel? Does that sound familiar? You guys remember that? Okay. And then we get this guy.
That was zero, just.
Oh, I'm sorry.
No solution?
You would say all real numbers. Because it doesn't matter what x is, it will always be true.
What
Yeah.
if we put zero?
Huh?
What if we put zero? You wouldn't want us to write not all real numbers.
Oh, if it was negative 6 equals negative 5, the answer would be no solution. But it's negative 6 equals negative 6, which means it's always true. Doesn't matter what number you plug in. So what's the answer? What makes it work? All real numbers. Yeah. Because your answer is always what makes this statement true. So on this one, only a value of 1 makes it true. On this one, anything you plug in makes it true. Somebody give me a number. 3. If I make x 3, let's see if this is true. 3 minus 2 is 1. 3 minus 3 is 0. Does 3 equal 3? Yeah, so it doesn't, any number you imagine, plug it in, it will work. Okay, I like it. Why does it work that way? Because the equation does not give a shit what x is. Because what happened to the x's? It died. Not a life lesson, kids. So since the x's died, they end up not having any influence on the equation. So that's why the answer didn't care. It was either always works or it never works. Okay. What about that? Has anybody ever seen that sequence before? And you're all like, seen that sequence before? What? I love it. I'm sorry. It just sounds like a math. Have you ever seen this movie before? And you're like, no, I haven't seen that sequence before, math boy. Has nobody ever seen that sequence before? All right, all right. Did anyone figure out what that sequence does? What'd you figure out?
So, so like 1 plus 1 equals 2.
Good.
1 plus 2 equals 3.
Good.
2 plus 3 equals 5. 5 plus 8 equals 13. 8
Good.
plus 13 is 21.
So everybody see that? Did anybody else figure that out? Now's your time to go. I didn't, but I'll say, oh, good. All right. No, you're good. You're good. I trust you. Jeff. So this is called the Fibonacci sequence, after a dude whose name was Fibonacci, which makes sense. If you read the Da Vinci Code, the Fibonacci sequence shows up at the beginning of that. It's scrawled on the wall above this dead body. So it's like, oh, good for math, great. People don't hate us already, and now we're involved in a murder. Shit. Real quick, Fibonacci sequence. I could teach an entire year's worth of things related to the Fibonacci sequence. I'll just say this. The most immediate thing that comes to mind is I was just in Canada. Over the summer, I went up and drove across Nova Scotia and all that stuff. Really cool. Sorry. In Canada, do you know how many countries don't use the metric system? It's 1 now. It used to be 3. Could you grab that door? Thank you. The evil door. It used to be 3. 1 adopted it, and the other one just recently got it through an adopted metric. We are the only country, because we're American. When I was in Canada, the Fibonacci sequence is perfect. 5 miles is roughly 8 kilometers. 13 miles is roughly 21 kilometers. It's because if we keep going into Fibonacci, somebody have a calculator right there? Anybody? And you're all like, I don't, because you said I couldn't use it. You got one? What is 13 divided by 8? Did you have one? I'm sorry. I'll put you on the spot. What do you get?
So you again?
Well, 13 divided by 8.
1.625.
And what's 21 divided by 13?
1.615384.
It'll keep bouncing, but it's going to eventually get to about 1.618. 1.618, blah, blah, blah. Sort of like the pi. You guys know pi? I'm not sure if pi or something, but apple. No, pi, 3.1415. Nice, blah, blah, blah. You guys with me? If I keep going in the Fibonacci sequence, it's going to kind of converge. When I divide, it's going to converge to a number. That number happens to be the conversion number between kilometers and miles. Almost, it's not perfect. Yes? Just randomly. Just coincidentally, which is so neat. I'll shut up now. Sorry. This is not going to be the test. Just to show you, like a regular sequence you would be used to, what's this one? What's the idea in that sequence there? Yeah, I'm adding 3, right? Do you guys see that? We keep adding 3. So then the next number would be 10. What about this sequence here? You can do it, Jeff. Multiply by 3. I like it. Okay, right? So when you give in a sequence, you're looking for the pattern. 2 of the most basic patterns are based on addition or subtraction, multiplication or division, right? Now, Fibonacci shows you that's not the only options. You can have other ways to build the next number, yes? And on one level, it feels like just playing around with shit, but you would be amazed at how what we discover from playing with sequences, how it actually informs real life stuff. Okay, so we might talk about that a little bit in chapter 1, yes. All right, guys. Any questions from this stuff?
How do you figure that number 4 again? How was that?
Oh, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. So to get the next number, you add the 2 before it. So that kind of sequence requires 2 seed numbers. Now listen. I've already put some of you guys into a semi-sleep condition. I understand. I can see your eyes kind of like, your eyes are open, but like this. I'm gonna hazard trying to go a little further with this. If you start, see how that one starts with 1, 1? That is the Fibonacci sequence, right? If you start with any 2 numbers and just keep going, they will always, when you divide 1 by the one before it, it will be the same number, 1.1, 1.618, blah, 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 blah. That is a little tricky, yes? Pick any 2 numbers, well, you gotta be careful. Pick 1 and -1, you get trapped. 1 minus 1 is 0, plus 1 is 1 minus 1 is 0, you know, it's like you can't, it doesn't go. So if you pick almost any 2 numbers and you just kind of follow the pattern of adding 2, you'll always get to a point where it divides 1 by the one before it into 1.618. Neat. We call that the golden ratio. And then you get like golden rectangles and you get all this weird shit. Okay, I'll stop. All right, I put some of you further into sleep. I'm sorry. So let's do this. I want to talk about something I overheard one group talking about, and then we're going to do a little bit from chapter 2. Yeah, I'm going to try, what is it, 210? Maybe I won't. Oh, we'll see. Does anyone know how to tell if a number is divisible by 9? Like if I just plot down that, do you know how to check, without putting in your calculator, do you know how to check if it's divisible by 9? Anybody? Yes?
I think it just like flips and it doesn't. Because I thought 54 isn't just 12.
Oh, that's a neat thing that happens with 2-digit numbers, sure. But it's related to the actual idea. What is 5 plus 4? Give me another, what's 9 times 8?
7.
What's 7 plus 2? 7 plus 2?
Oh, plus.
Yeah, you're good. You guys with me? All right, listen. What's 9 times 12? 108. What's 1 plus 0 plus 8? Sorry. So any number, if you add up the digits and the answer is a multiple of 9, 9 goes into that number. So let's see, 3, 6, 11, 12, 18, 27, 29, not a multiple of 9. You with me? So 9 would not go into that number. You guys kind of with me? But if I put, if I was more careful, oh God, what did I say, 29? So let's say 1, 6, good. So now it's gonna add up to be 36, I believe, if I did that right, yes. Now 9 will go into the number. If you want to test me, put that number in, divide it by 9, you'll get a whole number. Has anybody ever heard of that before? Some of you guys? Do you know how to tell? Okay, 2 is easy. How do you tell if something's divisible by 2? It's even. How do you tell if something's divisible by 3? Same rule. If you add up all the digits and it's a multiple of 3, 3 goes in. It makes sense because 3 and 9 are a multiple, right? Yes? What about 4? Say again.
The last two.
Last two digits. If I have the, like that number right there, holy shit, good job, John. What are the last two digits? 16. Does 4 go into 16? So 4 goes in the whole thing. Why does that work? 4 quarters is, so 100 cents. 4 goes into 100. Therefore, 4 goes into 104, 108. You with me? 4 goes into 200. Therefore, 4 goes into 204, 208. So all that matters is if the last two digits are divisible by 4, the whole damn thing is. I guess, does anyone feel like you have never heard this in your entire life? Do most of you feel like you've heard this before? Does anyone not want to respond to my questions in any way? Huh?
This particular.
Sorry? This one it works. So 9 goes in and 4 goes in. So guess what? This is also divisible by 36. Because 9 and 4 goes into it. Okay. Sorry, I'll stop there. So just to give you a little preview, chapter 2. The reason I start with chapter 2, by the way, let me just tell you some of my pedagogy here. Chapter 1 is related to word problem stuff. And normally, if I utter that phrase, I can see visibly people get sick a little bit. So I like to start with chapter 2, which is a little more sink your teeth into it, kind of like it's talking about sets and elements of sets and stuff like that. Venn diagrams, have you guys ever heard of a Venn diagram? It's like the two circles and they might overlap. You know, stuff that you can kind of like, you're familiar with a little bit. And then I'll go back and do chapter 1, and then you feel a little more confident in the class itself. And then I can start to try to give you ideas about how to solve wording problems. Are you with me? The first time I taught this class, I started with chapter 1, and I turned everybody off, like right off the line. Go fast. I'm like, damn it. So now I'm like, let me do chapter 2 first, just to get everybody in. Yes? Okay. So we're going to talk about stuff like, you guys have seen this notation before, yes? You know, if I was a little more careful, the set notation is this, yes? But this is what it looks like when I'm just drawing right real quick. Is 2 an element of A? You with me? 2 is in it. Is 2 in the set A? Therefore, 2 is an element of A. So the way I would represent that is 2 is an element of A. Is 7 an element of A? You're not going to believe what I'm going to do now. 7 is not an element of A. That's nice. Do any of you write the number 0 like this? Good. Oh, you do? Stop. Because what this means is empty set. So if I said, what is the set of all numbers where the number is 1 more than itself? Is there any number that is 1 more than itself? Don't overthink this. No. So that set would be empty. That's the symbol I use to represent empty set. So if you make your zeros look like that, I don't quite understand what you're trying to say. Because if 0 is in a set, is it empty? Is that an empty set? Because it has 0 in it. Yes? Poor little 0 dude. Okay, I think that's enough for today. That's plenty. So I recorded the lecture, so you can go grab that off of YouTube later if you want to or not. It's there if you miss a class or just to augment your notes. By the way, the fact that I record lectures does not mean this still becomes an online class. You must come to class. This is just supplementary. Yes? It helps me out too because I'm like, did I say there's a quiz? And I can go back and, oh yeah. All right. So if anybody